Fractions, decimals, and percents. Part 2. Lesson objective: compute relative frequencies for a frequency table. Let's begin. A frequency is the number of times a value occurs in a dataset or table. A relative frequency is the fraction or proportion of the frequency divided by the total number of outcomes. So, relative frequency is the frequency relative to all the values in the data set. We have this formula: relative frequency equals the frequency divided by the total. Let's do some examples. In the recent MAT 131 student survey, 113 students answered the question, "Do you smoke?" 11 students stated yes. What is the proportion of the students who reported that they smoke? Express as a fraction, then as a percent rounded to the nearest hundredth. So we are given that out of 113 students, that's the total number of outcomes, 11 reported that they smoke. That's our frequency. So the proportion of students who smoke would be the frequency divided by the total. So in this example, the frequency is 11. 11 students out of 113 stated that they smoke. To change this to a percent, we first change the fraction to a decimal. We take 11, we divide it by 113, and we get approximately 0.0973. To change this decimal to a percent, we multiply it by 100. That's the same thing as moving the decimal place 2 places to the right. So we get 9.7345 and so on percent, and then we finally round the percent to 2 decimal places. The second decimal place is a 3, so since the number to the right is less than 5, this does not round up. So it's simply 9.73%. So what this number tells us is about 9.73% of students are smokers. Now we can also say about a little bit more than 90% of students reported that they're non-smokers. Let's do another example. In the recent MAT 131 student survey, out of 113 students, 13.3 reported that they are left-handed. How many students reported that they are left-handed? So in this example, we want to find the frequency. We want to find the number of students who are left-handed. Now we know the total is 113, and the 13.3% is the relative frequency. So our first step is to change the percent to a decimal. So 13.3%, if we divide the percent by 100, we get 0.133, or we can simply just move the decimal place 2 places to the left and drop the percent sign. Substituting 0.133 for the relative frequency, and for the total we have 113. We have this equation. So I want to find out what is 0.133 of this 113. Or another way I can think about it is I want to get the frequency by itself. So I do the opposite. The opposite of divide by 113 is to multiply by 113. And this gives us 15.029. Now because we are talking about the frequency, this will need to be a whole number. We can't have a fractional part of a student. So of course we round this to the nearest whole number, and that gives us 15 students. So 15 students out of the 113 are left-handed. Now we can always double check this. If we take 15 and we divide it by the total 113, we should get something very, very close to 13.3%. Compute the relative frequencies for the frequency table, expressed as a percent rounded to the nearest tenth. So this is involving the variable ghost. Do you believe in ghosts? 40 students, reported no, 22 reported not sure, and 50 stated yes. So if we add these three frequencies, we should get 112. That's the grand total. To get the relative frequencies, I take each frequency and I divide it by the total, 112. So we have 40 divided by 112. For the next cell, we have 22 divided by 112. And lastly, we have 50 divided by 112. To change these to a percent, we first change them to a decimal. So we take 40, we divide it by 112, and we get approximately 0.357, which we change it to a percent becomes 35.7%. So almost 36% of the students reported that they did not believe in ghosts. For not sure, same process, we get 19.6%. And then finally, yes would be 44.6%. So these three values, these three percentages, are the relative frequency for the outcomes no, not sure, and yes. Now, once we start using raw data in StatCrunch, StatCrunch will compute both the frequency and the relative frequency for us. It's a good idea to be able to take a frequency table and change it to a relative frequency table, because there are times that we may not have the raw data. So this would be our relative frequency for this table. Thanks for watching.